Hi everyone, this is Casey here. We are going to be learning today about some new techniques for finding limits. We're going to start off with real basic stuff, and then over the next few days we're going to add on some new ideas. So far you've learned about limits primarily with a graph. Okay, so for instance, something like this thing right here. This is the function f of x equals x squared minus 4x plus 5. And if I asked you to find the limit as x approaches 2 of that function, so far you would have looked at the graph and gone, okay, there's x equals 2. The y value there is equal to 1. Or if I had asked you for the limit as x approaches 4 of the function, then you would look over at x equals 4, go up on the graph, and you get 5 as an answer. So that's a lot of what we've already done, looking at it graphically. But we don't want to always have to do things with the graph, because there are times when we don't have a graph, or finding a graph or taking the time to do the graph is just longer than necessary when you can do the problem algebraically. So we can do problems like this simply by doing some basic substitution. So I am asking you the question, the limit as x approaches 2 of this function. Okay, so there's the function again. And what we'll do is we'll just substitute 2 in for x, because that's all this really is right here. It's just a point on the graph. So I put 2 in for x, I get 2 squared minus 4 times 2 plus 5. And we get 4 minus 8 plus 5, which is equal to 1. Okay, this is what we would call the direct substitution method, where if you know the function, you can just substitute the x value, the x that you're approaching, into the function. Apparently, we see that I put this on the wrong slide. So here we go. Continuing on. All right, so 3 problems to show you, and then we're going to do one that's a little bit trickier, or a few that are a little bit trickier, I guess. So, all right, so here we have the limit as x approaches 2, and then we have this rational function. These are the ones that are a little bit more cumbersome to graph, unless you have decimals in front of you, but pretty easy to do with substitution. So once I substitute the 2 in, I don't need to write the limit anymore. If I have to do something else to the problem, I will need to write the limit again. So this is 3 times 2 minus 4 over 2 plus 1. 6 minus 4 is 2. 2 plus 1 is 3. We get 2/3 for this. So this literally means that the point 2 comma 2/3 is on that graph. Next one, I'm going to substitute 3 in for x. So 2 times 3 squared over 4 times 3 minus 1. I get 9 times 2 is 18 over 12 minus 1 is 11. And again, this literally means that the point 3 comma 18/11 is on that graph. The last one here is actually sometimes easier to explain by drawing a quick sketch. So remember that this piece in here is standing for a function. So what that literally means is that f of x equals 7. Well, we hopefully know that f of x is the same as saying y equals 7. And what that also really just means is that I have a horizontal line at y equals 7. So if I'm trying to find the limit going towards any x value, if I have a horizontal line, the answer to it will just be that value of the horizontal line. So in this case, that's 7. It wouldn't matter what number was here at the x, as x approaches, it would be that answer. So if this were like x approaches 12, you'd still have 7. Okay, so now these problems are giving you some information in a different way. So instead of me giving you the actual functions, I'm just telling you basic information about the limits. So the first part is the limit as x approaches 6 of the function f of x is equal to 9, and the limit as x approaches 6 of the function g of x is equal to -5. This is basically to show you that normal multiplication, addition, subtraction, square roots all work in the same way with limits as they would on normal mathematical problems. For instance, on this one here, I know that the limit as x approaches 6 of f of x without the 2. So the f of x part is equal to 9. And then I can take and multiply the 9 answer by 2 so that the final answer is 18. You can also think of it as factoring the 2 out front, if that is easier for you to see. So if I put it like that, then again, I know that the limit as x approaches 6 is equal to 9. 9 goes in this spot, times 2 is equal to 18. Next one, same basic idea. So I know the limit as x approaches 6 of f of x is 9. And I know the limit as x approaches 6 of g of x is negative 5. And that 3 just stays there. Or you could factor it out front of the limit as a 1/3, if that makes you more comfortable. Either way, we're going to reduce, and we're going to get negative 3/5. Next one, you could do a variety of things with this. So you could take the square root of 4, which is 2, and put the 2 out front over here. You could leave it here and substitute the 9 into the problem here and take the square root of the answer. It doesn't matter. So I'm going to do it both ways so you can see what I'm talking about. The limit as x approaches 6 of the square root of 4. And then I'm going to now take that 9 and substitute it in. So technically, I don't even need this anymore. I'm just doing the square root of 4 times 9, which is 6. Okay. Or if you'd rather, you could take that square root of 4, which is 2, put it out front. The limit as x approaches 6 of the square root of f of x. Put the 9 in for the f of x, and you get the square root of 9 is 3. 2 times 3 is 6. All right, moving to the right. So same process, right? So I'm going to substitute 9 in for f of x, so 3 times 9. And negative 5 in for g of x, and simplify. So I get 27 plus 10, which is 37. Last one. Oops. So now this one is actually a little more complicated when you look at it, at least. So you have these two pieces here, the x and the g of x. So what that means is you are going to need to substitute g of x is equal to negative 5. We're going to substitute negative 5 into the limit for the g of x part. And then we're going to substitute that 6 in for x. So we'll be doing 6 times negative 5. So remember when we were doing these on the first screen, anytime there was an x, I substituted this limit value in. So I'm putting a 6 there. But this is really saying what is the limit as x approaches 6 of g of x, which is the negative 5. So this gets replaced with negative 5. And the whole thing is equal to negative 30. There is a Math Excel that goes along with this, but there's also a worksheet on the calendar that I think would be really useful for you as well. So I would highly recommend that you visit that, take a look at it, see how it goes.